Hi, my name is Roman. I'm from Releem. I'm happy to speak here today, and the topic of this conference is very close to my work. And today I want to share our experience working with teams that run production databases without database administrators. And this talk is not about replacing database administrators. When a database administrator is present, many of these problems simply don't exist. This is about what happens when database work become part of someone else's jobs. And usually a developer or founder. The main idea I want to share is simple. The hardest part is not fixing databases. The hardest part is deciding what we should fix. And before we move forward, I'd like to tell about my first-hand experience. I'm a software engineer and founder of Releem. Releem is a cloud service that helps developers to manage and optimize databases. I've been using MySQL since 2008 in a variety of roles: developer, support engineer, database administrator, and over 15 years consulting and managing MySQL servers. It is our agenda today. I'll start with how small teams usually manage databases today. Then I'll show the real tasks developers do. After that, I'll explain the main decision problem we kept seeing. And then I'll show how we approach this problem, and I'll walk through the workflow we ended up with, and finally, I'll share what changed in practice. And I want to start with a point. When a team has a DBA, database management is usually not a big problem. There is someone who knows what matters, what is risky, and what can wait. Decisions are faster and more confident. And everything I'll talk today mostly applies to teams without this role. And in most cases, the database is owned part-time by developers. There is no dedicated DBA. And database work happens in the gaps between feature development and the production incidents. Because of this, issues are often noticed late. Very often, the first signal comes from users. There is plenty of advice available online, different blogs, but it's hard to know what to trust. And testing ideas in production takes time and effort. And over time, teams learn one thing: fixing the wrong thing feels riskier than doing nothing. And this is how teams slowly become reactive. And after seeing how small teams work today, it's important to look at what developers actually deal with. And database work is not one big task. It's many small decisions. Which queries are really slow, which index to add or change, how to tune parameters without breaking memory and others. And none of these tasks are impossible. The problem is having to solve all of them without enough time or deep database expertise. And to understand why database work feels heavy for small teams, it helps to group it into a few clear areas. In practice, almost everything teams deal with falls into these four categories: performance, resource usage, reliability, and security. And what's important is that these areas are not independent. A change in one often affects the others. And this is why database work is not just about fixing one metric. It's about understanding the system as a whole. And to manage databases, teams use many different tools. It's monitoring and observability platforms. It's specialized tools for tuning or query optimization, custom scripts for schema and security checks, blogs, documentations, and more recently, LLMs. And with this approach, there are a few clear challenges. And the first one is how monitoring and observability are usually used. And these tools are very powerful, but they are mostly designed for DBAs. They expose a lot of raw signals, metrics, graphs, logs, traces. And to turn these into an action, you need deep database context and experience. And for developers without background, the hardest questions remains unanswered. What should I change next? And monitoring shows that something is happening. It doesn't tell you what to do about it. And the second challenge comes from using many specialized tools. There are good tools for configuration tuning, query optimization, for schema checks, and for security. The problem is not the tools themselves. The problem is that they are fragmented. Each tool looks at only one part of the system. None of them sees the full workload context. Because of this, developers have to connect everything manually. They collect information from one tool, then switch to another, and try to decide what to do next. And in the end, almost all actions are still manual. This takes time, and it increases the risk of changing the wrong thing. And the third challenge is execution. Even when teams know what needs to be changed, almost everything still has to be done manually. Adjusting indexes, applying configuration, cleaning up schema, all of these requires time and attention. And so the core problem looks like this. Looking at these challenges together, we believe that the current approach could be improved, not by replacing existing tools, but by changing how decisions and actions are connected. And we didn't try to give teams more dashboards, and we tried to reduce the cost of decision making. The idea was a database advisor, something that helps decide what to focus on next, with safety first, and automation is optional. In practice, this means a few things. Look at real workload behavior. Analyze performance, resources, reliability, and security together. Propose specific action, configuration, query optimization, schema. And the key idea is simple. We automate the work where teams lose time doing the same analysis. At the instance layer, teams spend time figuring out whether CPU, RAM, or storage is enough. These checks are repetitive and similar across many environments. At the operating system layer, the work is also repetitive. Teams often review the same operating system level settings when running databases. Automating these checks reduces manual effort. And the database service layer is where teams usually spend the most time. And configuration tuning, query optimization, index and schema checks. And automating the analysis and recommendations removes a large part of manual investigation. And this slide shows how we move from raw data to an actual recommendation. And the first, workload data collection. This is where we collect information about how database is actually used in production, queries, load, latency, and this gives us the real context. And the second part is pattern detection. Here we look for signals in the data. Statistics help us see change and trends. Machine learning helps group similar workloads and prioritize them. And the goal of this step is to find things that are worth attention. And the next step is action hypothesis. Based on detected patterns, we generate possible actions. For example, a configuration change, index suggestion, or query improvement. Some hypotheses come from rules. In some cases, LLMs help suggest ideas based on context. But at this stage, these are only hypotheses, not decisions. Then comes impact estimation. Here we try to understand what effect a change might have. For example, will it reduce latency or increase memory usage? And after that, expert system. This is a set of explicit DBA rules and constraints. It checks whether an action makes sense for this database and this workload. And only after this step, do we get validated actions. These are concrete recommendations that are scoped and explained. And then comes execution. Teams can apply change manually or automate them if they want. And finally, we look at feedback impact. We use metrics to see what actually happened after the change. The main goal of this workflow is simple: reduce time team spends figuring out what to do next. We collected this workload data to make decisions. We collect focused workload data, resource usage, configuration, schema, metadata, and query statistics. And this data is normalized and aggregated. Based on this workload view, we can make practical and safe recommendations. And this is the architecture of Releem platform. We use an agent that runs close to the database. In many ways, it looks like a classic monitoring agent. It collects database metrics and system level data. This data is then sent to Releem cloud platform. That's where analysis happens and recommendations are generated. And for teams, the main interaction is through the dashboard. DBAs or developers can review recommendations and see explanations and decide when and how to apply them. And the important difference compared to traditional monitoring is the agent is not read-only. It can also perform actions. For example, apply configuration change, But it only does this when the team explicitly allows it. Otherwise, it works just like a monitoring agent that provides context and suggestions. And the result of all these is that teams end up with one dashboard. Instead of jumping between different tools for configuration, queries, schema, security, everything is in one place. The dashboard doesn't try to show every possible metric. It focuses on what needs attention and what can be done next. Teams see recommendations across performance, resource usage, reliability, and security in a single view. This reduces context switching, less time spent searching for information, and more time spent making decisions. The main goal here is not visibility, it's clarity. And deadlocks are a good example because they are very common but often misunderstood. On the screen, teams don't just see that deadlock happened. They see which tables were locked. More importantly, they also see why this deadlock happened and what can be changed to prevent it. Here is another example with a query optimization. This query was already optimized and measured. Teams could see the original query, the recommended change, and the expected impact before applying it. After the change was applied, the system tracked what actually happened. Query latency, execution time, load and total time. So instead of guessing whether an optimization helped, teams can see the result in real numbers. In practice, this makes query optimization less risky. Developers don't need to rely on theory or assumptions. They can see this change was applied and this is what improved. And regarding compatibility, Releem works with MySQL and MariaDB today. Postgres support is something we are actively working on. It supports both self-managed databases and managed services, AWS RDS and GCP Cloud SQL. And I want to share a few numbers from what we see in production. This is real usage data. And the main takeaway from this is simple. Most database problems are not unique. The same patterns appear again and again across different workloads. That's why reducing manual investigation and reusing existing knowledge saves so much time. And I'll finish with what actually changed for teams. And they didn't start spending more time on databases. They started spending less, but more regularly. Instead of waiting for problems, teams checked recommendations and apply small changes earlier. A lot of manual work around configuration and query tuning disappeared. As a result, emergency incidents became less frequent. And probably the most important change, database work became clearer and more predictable, not stressful and reactive. That's the experience I want to share today. Thank you.